Hello everyone, in this presentation we are going to talk about composition and aggregation relationship in Java. Objectives of today's lecture is to become familiar with the two relationship types, aggregation and composition, to design system by identifying the classes and discovering the relationships among classes, and implement Java code segment in classes design that follow relationships guidelines. In this diagram, we represent a new relationship between classes that has a name has a relationship. As you see here, the vehicle class, just implemented in UML diagram, has relationship has a with engine, has a with transmission, and has a with a door. So basically, the car component, engine, door, test transmission, though they all depends on aggregate, which is vehicle. So in this diagram you see a relationship between aggregate car, between class car, wheel, engine and seat. And the number that you have here, it represents how many objects of this particular class required in relationship. Car has 4 wheels, a car has 1 engine, and potentially car has from 1 to more to many seats. This also has a relationship. The multi-class hierarchy is example with even more classes. You see here the car has engine, and engine has pistons and spark plugs. Car has stereo, and stereo has radio, cassettes. The radio has a tuner. Also car has door, and door has handle. In this case, you see how the class relationship can be expanded based on the area of the main. So let's talk about aggregation first. Aggregation is a part of a relationship between classes when parts may be living without whole, and aggregation contains collection of those parts. So the whole part has this white diamond, and the part is connected to the whole part using this diamond. For example, one test contains collection from 0 to n questions, and you see here the questions may belong to the test, and there is one too many questions in the test. At the same time, we understand the question can exist without test. Shared aggregation, it's kind of like an end-to-end relationship between class and students, for example. So list of students for class is still changing. It doesn't matter when student or class deleting or creating. We have relationship many to many between classes and class and student. Composition. The composition is much stronger than aggregation. A composite entity does not exist if all parts don't exist. For example, parts are created with a whole and die with a whole, or completely useless. So whole in this case and part connected in the same way, but the diamond is black. For example, the car has 4 wheels and car has engine, just one. A human has a brain and just only one brain. So basically, this all parts doesn't really exist without container, which maybe that makes sense to understand that composition is much stronger than aggregation. So as a summary, aggregation and composition are modeling has a relationship. If an object exclusively owned by an aggregated object, the relationship between the object and its aggregated object is always referred to as composition, otherwise aggregation. For example, in this simple diagram between 3 classes, name, person, and address, you see that name has black diamond close to the person, and address has white diamond close to the person. So we assuming that person address connected using aggregation, and name and person using composition. Decision regarding aggregation or composition is subject to the main area. For example, if we believe the person must have an address, it will be also composition. So this is also a question to discussion between white and black diamond. So now it's your turn. Define relationship. I would ask you to spend some time with these slides, and one diagram reflect a relationship between person, hand, and heart, and diagram on the right show relationship between city, tree, and car. The question is, what are the relationships between classes? So in this case, we will try to identify one project that has three classes: name, person, address. You considered these classes before, and we will try to understand how to implement this relationship, first of all in UML class diagram, and then how to implement it in Java. So again, I remind you that name and person connected using composition, and address and person connected using aggregation. So basically, a relationship of this between these classes is composition and aggregation, and we reflect this in UML class diagram. So in this case, this is a full UML class diagram. So what is this? Specifically, name is the class that describe name as a class with the three properties: first name, middle initials, last name, and bunch of method. Address is described as a class with the street, city, state, zip, constructors, and getters and setters as well. And person has only two instance variables: name object of class name and address object of class address. This is basically how we implement composition aggregation in practice. So how to implement it in Java? An aggregation and composition relationship is usually represented as a data field in the aggregated class. So that's what I repeated again. So class name with data fields constructor and method, address class with data fields constructor and method, and object variables, two instance object variables in class person. In Java, there is an opportunity to create inner class. So if the name and address or address class is used in the person class only exclusively, then can be declared as inner classes inside person class. So for example, you see here that the name and address class, they define in the scope of the class person. It's a good decision if you know that these classes will belong to the person class and never used outside. In some situation, implementation required using arrays. For example, to represent a general binary relationship that describes an activity between classes, we can use arrays as the following. Student could have from 1 to 5 courses, but courses have from 5 to 60 students. The course has one faculty or teacher, but faculty can teach from 0 to 3 courses at the same time. So in this case, we come up with the definition that class student would have array of course listed. Class faculty will have a list of courses, and class course will have array of students, class list, and private variable faculty, because the class or course can be taught only by one faculty. So this is pretty much how to represent array object variable, right? How to describe more complex relationship in classes. So that's pretty much what is briefly today for composition and aggregation. So we're going to study is a relationship next week, and I would like to give you some kind of introduction. So what is the difference between has and is? So let's say a vehicle, car, and truck can be considered as a relationship. And we would say the car is a vehicle with the additional property sunroof, and truck is a vehicle, in this case using the same abbreviation. So this is a relationship, and relationship between a class and its refined version has a name, inheritance. We'll study inheritance next week. Okay, so it was a brief introduction to class relationships, composition and aggregation. If you have any questions, please let me know. Thank you very much for your time.